Good afternoon, this is Don Allen, and today we're going to talk about the remarkable number 1. Let's take a little history first. The first two ways we use 1 is the ordinal, who is first, and the cardinal, how much and how many. So those are the two that are commonly used. 1 as an entity has been with us for more than 20,000 years. It first appeared on bones, carved as etchings on bones or notches on bones 20,000 years ago, and first appeared on a token about 8,000 years ago. The unit first appeared for construction about 3,000 years ago. This was about the time that the Great Pyramids were being built. We'll consider 5 forms, the only 5 forms I think there are, of the number 1. There's the ordinal and cardinal, which we've just mentioned. There's 1 as a unit, say like an inch or a mile or a meter. There's a 1 as a state, and then there's 1 in a relational way, 1 to 1. So let's take them in turn and discuss them along the way. The ordinal one, first, second, third. There's no date of origin. It's probably more than 300,000 years old. The idea of ordinality, as you have seen in the nature films, there seems to be an alpha leader of every animal group, and that's been going on for more than a million years. The alpha leader has priority to eat. He is first to eat, or she is first to eat, and the priority for all benefits. There's also the priority of rights. That is an ordinal use of the number 1. The cardinal one is the one we use more often. It's for counting and arithmetic. Its earliest was as scratchings or etchings on bones. But you can see the bone in the picture, the Ishango bone. It has these notches carved in it, and it's not quite known what they were used for, but they're very deliberate, as you can see. Could be a calendar, it could be some sort of counting, or some sort of record keeping. The second use was in clay tokens. These were found at Susa, which is now in Iran. It's almost certain the use was for money, or perhaps counting and accounting. Please note that once you have a token for your 1, then you begin to have arithmetic, whereas with the notches there's no arithmetic there to speak of. So from arithmetic we get to algebra, and then to all of mathematics. Also, the cardinal 1 is used in binary representations. The next item on the agenda is number as a state. Well, what's a state? You got to get that down. Well, there's color, that's a state, density, temperature, magnitude, stability, and phase, and many, many more. I'm sure you can think of many states of objects in our universe. Usually, a state applies to an entire class, or even defines a class. The state of oneness, a la Bertrand Russell, is the state of those things, or those sets whose members have the property of being 1, namely sets with 1 member. This leads to other number states, such as the state of two-ness, 2 zebras, 2 pieces of chalk, 2 shoes, and so forth. It also leads to countability, as we'll see. Number is a unit. The origin, of course, is to measure distance, time, and money, although time and money came much after distance, I'm sure, unless we believe the Ishango bones are measuring lunar months. And this is not known either. The earliest known uniform system of weights comes from Mesopotamia, which contained Babylon and Egypt, and they were created during the 4th and 3rd millennia BC. The The cubit is one of the first units of measurement. It was used at least since 3000 BC. That's 5,000 years ago, and it is considered to be about 457 millimeters long. A cubit. It's not quite 2 feet. It's about a foot and a half. Unit is a considerably difficult concept for young students, particularly distance units, and that's because the distance unit can change a lot. It changes from one system to another system, and it causes a lot of difficulty for students, particularly in the essential application of forming fractions. Now let's look at number as one-to-one, counting without numbers. The Beda tribesmen of Sri Lanka used to measure their herds by one-to-one counting. That is, that for each goat they had, they would set aside one stick, and there set up a correspondence between sticks and goats, and they could keep a track or an account of their herd right within their dwelling. The abstraction, of course, is very important. It puts sets as equivalent by determining a one-to-one mapping between them. And as you recall, we have a very important definition of a one-to-one function where A is the domain and B is the range, and if f of A equals f of B implies A equals B, we'll say the function is one-to-one. These are very, very important type of functions in a lot of mathematics, including calculus. But number as one-to-one creates sort of a paradox or a conundrum, or it's counterintuitive, at least historically, because if you look at the picture there, you see two circles, one larger than the other, but from the center we can draw lines, and therefore we can find a one-to-one mapping between each point on the smaller circle to each point on the larger circle. This implies that the two circles have the same number of points, and this is counterintuitive. Galileo, before the idea of infinity or one-to-oneness or anything like that were invented, understood this type of counterintuition, and he realized it had something to do with infinity. And he says it was wrong. It is wrong to speak of infinite quantities being the one greater or less than or equal to the other. Simply different rules apply. Well, number as one-to-one leads to countable infinity. That is, all sets that can be put in one-to-one correspondence with the integers, and that includes algebraic numbers, even integers, odd integers, and just about everything else except numbers, all the numbers. It also leads to uncountable infinity. That is, sets too large to be put in one-to-one correspondence with the integers. Those are the real numbers, and there are other infinities beyond that. So this was the derivation or invention of George Cantor in 1874, when he discovered there are two infinities. So we would jump from zero infinity, or only potential infinity, a la Aristotle, and in 1874 there are suddenly two very, very different infinities. Uncountable infinity is basically beyond the scope of most folks, except for us mathematicians. Putting it all together, it's easy to put the ordinals into one-to-one correspondence with all the cardinals, and thus the notion of oneness to each, and by inference to all the units. One is also in the language. Unity. For example, in the topic of unity, we talk of one nation or one God. This is a sense of unity. It is a particular item. Red is one of her favorite colors. Or as a singleton, I think she is the one. Or in relational form, let's talk one-on-one. So one that pervades not only mathematics but the language as well. The conclusion is most of us use these forms transparently, interchangeably, without difficulty. However, note that when ever a single term or word is used in multiple ways, it becomes difficult, if not impossible, to give comprehensive definition, and that is why it is very difficult to define one, and you would do it one day in one sense and another day in another sense, and for you it would be the same, but for a young student, maybe not.